So Dr. Lindsay Pease at the University of Minnesota Crookston is going to talk to us a little bit about nutrient losses in tidal drainage and the research she's been doing.
All right, hey everybody. I will do my best to go quickly so that you can all be on time for your break. Hope everybody's having a good morning as I pull my slideshow up. Okay. Yeah, and as Missy said, I'm going to be just giving a really quick overview of nitrogen losses in tile drainage and the Red River Valley watershed. And this is just kind of a really brief summary of what we did this summer. And I will say that, due to some of the restrictions of the COVID-19 pandemic and limitations on having personnel in the laboratory, we really don't have a lot of data actually analyzed just yet. But I was able to kind of pull together a little bit. And if you saw my presentation at the Prairie Grains Conference, I'll be kind of doing a little bit of some of that, but then also talking about some of the bigger watershed projects, or really one of the big watershed projects that we're going to hope to be initiating this next year. So as you guys know, we are up in the Red River Basin watershed, and this is a really unique watershed, is that it's one of the only ones that flows north into Canada. And most of the state of Minnesota is in either the Mississippi River watershed or the Great Lakes watershed. And this really makes us, pretty unique in terms of, what sort of watershed management issues we need to be thinking about. One of those big ones is that since our water flows northward into Lake Winnipeg, we do have to be mindful of our phosphorus losses. Phosphorus is one of those limiting nutrients that is correlated with algal blooms developing in freshwater lakes. And since Lake Winnipeg is a freshwater lake, we do see that, phosphorus loss is being correlated with the size of the blooms happening in Lake Winnipeg. And we want to be good neighbors. And this is a map that came of a result of some modeling studies that really kind of supposes that a lot of the watershed load that is coming through the Red River, a lot of that does originate on the US side of the border. So this is just kind of the type of situation that, I saw develop in Ohio's Western Lake Erie Basin when I worked there. And if you've heard me talk before, you've probably heard me talk about that. So I'll skip over that today, but just know that, this is the kind of thing that for me sends up like kind of a little bit of a, maybe not a red flag, but a yellow flag of thinking about, okay, I've seen this happen before and go really bad for farmers. So that was kind of maybe some of the drive of trying to do some tile drainage monitoring. And this is with phosphorus, but everything kind of applies for nitrogen too. Just wanting to look at, how our fertilizer management does or doesn't correlate with losses in the greater watershed. And so what we started this past year, we started doing some tile drainage monitoring. We did some on farm. I had a few sites, the farms that either myself or one of my grad students would come and grab some water samples throughout the summer. And boy, this is an interesting year to start that process. As you guys all know, this was a very wet summer. These are just pictures that I took from around the Research and Outreach Center, where you can really see the effects of water that we saw just on our own research farm, that in Crookston. And we don't even farm, we farm a lot of acres, but or just around town, but we really saw it in all of our crops being affected by that heavy rainfall. And again, this is just kind of the rainfall distribution that we saw. We have the blue bars are 2020, but I also threw 2019 in there for comparison because we also had high rainfall in 2019, but you can see the timing of that rainfall was really different. And then the black squares with the dashed lines, that's our average, our 10-year average rainfall. And you can see that both years being really far off of our 10-year average compared to, that baseline. But this summer period is really when a lot of our tile drains are flowing. The crop is still developing, so we don't have a lot of that kind of transpiration or evaporation of of water from the plants taking it up and using it as they're growing. So this can be a really critical window for nutrient loss. And for just the 3 months of preliminary data that we do have, we really saw those nitrogen concentrations ramping up, a little bit lower in May, kind of most variable and not quite highest, but most variable in June, and then highest in July. And I thought this was really interesting to kind of look at in conjunction with that rainfall data. So I just kind of superimposed that image from the last slide onto here. And you can see those concentrations really ramping up along the same kind of scale as our rainfall data. So you can really actually see in the concentration data, just those grab samples out of the tile drainage, that we are getting higher nitrogen concentrations, and that correlates with the rainfall. And I don't have an exact statistical analysis of this yet. That will be coming soon. But I do think that just looking at this data visually, you can see a correlation, and I'm really interested to kind of run the stats on it and see, is this trend statistically significant, and kind of do we see this throughout the rest of the growing season, which was a little bit drier. And this actually matches up with what I've found previously in some of Ohio's lakebed clay soils, really seeing that high weekly cumulative rainfall driving nitrate concentrations showing up in tile drainage. So in a lot of ways, this is what I expected to see, because the nitrate losses are really driven by water flowing through the soil. So again, we had really high weekly rainfall. We had, 6 to 8 inches of rain in the summer alone, and that's really the conditions that you would expect to see a lot of nitrate moving through the soil. And for phosphorus concentrations, it's a little bit different, and I'll just kind of throw this up here just for comparison. Really what you look at for phosphorus concentrations are one really big rainfall event. So like a 3-inch rainfall event or a 2-inch rainfall event, that's gonna maybe push phosphorus losses off farm. But nitrate's a little bit more tied in to kind of your soil moisture levels. How wet is it? How wet has it been? Kind of what are those antecedent conditions, is kind of a scientific way of saying like how wet are your soils when the rain happens, and that's kind of when we see that fertilizer really moving through the system and out the tile drains. So what's next? We are, as I mentioned, still continuing our laboratory analysis of what we collected this past growing season, and we want to pair that data with rainfall, and we also want to continue collecting grab samples through this next year, just to kind of help supplement that data set. And we're gonna have a different rainfall pattern this next year. As you can imagine, who knows what it'll be like, but it will be different. And really want to look at those trends between kind of what's happening with the weather, and then how are we seeing that fertilizer move through the system. But then I also will be beginning a really big watershed project starting this spring. And we're already in talks about how exactly we're going to coordinate all of this. But this is going to be a little bit more of a Red River Basin edge of field network. I have a lot of partners involved in this project, and this work that I started this past year and I talked about is going to tie into this bigger effort. And really, this is going to be a multi-year coordinated project working with some of the discovery farm sites that Minnesota Department of Agriculture manages, and also with our Canadian partners in University of Manitoba. You guys all know David Lobb, who worked on some phosphorus losses from crop residue. That's always a hot topic up here. And David Lobb, I'm partnering with on this project to kind of look at his sites in Canada and compare that to our sites in Crookston, and then also kind of the sites that are closer to the southern part of the basin, south of Fargo. And NDSU, I'm working with Amit, who you guys all know from his on-farm work as well. And yeah, from NDSU. So what our big picture question that we're going to be answering is, does this kind of 4R fertilizer management strategy that all of us from University Extension have been talking about for a long time, does that really work? A, for maintaining your crop yield, and B, for minimizing your phosphorus loss and your nitrogen loss for that matter too. We're going to be looking at both nutrients, and even though phosphorus is kind of that key component of algal blooms in Lake Winnipeg, nitrogen is still important too, and obviously nitrogen's that more dynamic fertilizer application, for you guys. The nitrogens can change really in the system a lot too, and so that's also important. So with that, just my really quick summary is we did see rainfall correlating with nitrogen concentrations in the tile discharge, a more full analysis coming soon, but these findings are going to tie into this bigger Red River Valley watershed effort, and that's going to be ongoing for the next several years. So I am really excited about that and kind of some of the opportunities, and those on-farm sites, these sites that I mentioned in those previous slide, those are all on-farm sites, kind of more production scale rather than plot scale. So I should mention that too. But one of the sites is my drainage plots that I have in Crookston. But as you guys know, we do manage that as a production scale farm, and not as kind of individual research plots. So we're going to get some really cool on-farm production scale data off this project, and I'm looking forward to bringing that to you in the future. So thanks everybody, and with that, I will take any last questions, and thanks, Missy.
All right, so we got in one question here. It says, I was under the impression phosphorus was not mobile or leachable in the soil. Since phosphorus in tile water was seen only after heavy downpours, could it be possible the phosphorus came not from the tile, but from erosion?
Yeah, so so your impression that it's not mobile or leachable is right in a sense. It's not as mobile as nitrogen. The issue is that it only requires a really, really small amount. We're talking, for nitrogen to be an issue in freshwater systems, you're looking at 10 parts per million. For phosphorus, it's 0.04 parts per million. So that's like 2 orders of magnitude smaller. So while your losses aren't very much, they can potentially, magnify as everybody's losing a little bit downstream. So the second part, so the first part of your question is that it doesn't move, a lot of it does not move, but the amount that does can be environmentally significant. The second part of your question, could it be erosion losses? Well, we do look at the sediment moving in the tile lines and in the surface water too. And I will say surface runoff is definitely a bigger source of phosphorus than tile drainage. So yeah, sorry if that wasn't clear. I kind of skipped through that a little bit. But yeah, tile drainage is a lesser source of phosphorus, but again, just that little bit that does move through the tile doesn't mean you're not losing anything, and doesn't mean that it's not potentially impactful downstream. And that's kind of what we're trying to answer too, is how much how much that matters, and how much tile drainage versus surface runoff, and really get more of that quantitative answer for you all.
All right, we've got one more question. Are you looking for more sites at the very south end of the basin? And I should say sites in general.
Yeah, sites in general. I think if you guys are interested in, working with us on this project, I am definitely open to, looking at more sites, different sites, even if it's just kind of more that grab sampling than the intensive, daily monitoring. So please feel free to reach out to me. My email is on the screen, but then also you can ask Missy you can pass it along to Missy, and she'll pass it along to me too if you can't get in touch with me. But yeah, always looking for more people who are interested in this kind of work. So thanks.